Rate of change, smoke height. So consider this as a test problem. Read the question, pause the video, solve it, and then look into my suggestion. The question is, the smoke emitted from a chimney forms a right circular cone, the height of which is 3 times the radius. If the rate of emission of the smoke is 225 meter cube per minute, how fast is the height increasing when the radius is 10 meters? So when we read this question, we should write on whatever is given to us. So it says, if the rate of emission of the smoke is 225 meter cube per minute, that means dV dt is given to us, right? So dV dt is equals to 225 meter cube per minute, right? How fast is the height increasing when radius is 10 meters? So we want to find dH dt when radius equals to 10 meters, right? And also we are given that the smoke emitted from a chimney forms a right circular cone, the height of which is 3 times the radius. So we are also given that h equals to 3 times the radius. So all these things are given, and this is what we need to find. So that is basically the question. And here in the question we are talking about a circular cone. So that means the smoke is coming something like this, in this fashion, right? So that is kind of a circular cone, and where this radius and the height are related, right? So height is 3 times the radius. That kind of a structure is there. Now fortunately for us in this particular question, we are already given a relation between height and radius, so we don't have to bother much. But most of the time this relation will not be given to us, and in such cases when we are talking about cone, we use similar triangles to find this relation, or sometimes the volume is given, then we use that volume to find these relations, right? Now here we are given the relation, so we'll not bother about that part, correct? Now let's look back into the question and try to understand how to solve it. Now what is the volume of a cone? So volume of a cone is 1 by 3 pi r square h. The volume of a cone is 1 by 3 pi r square h, right? So of a cylinder it is pi r square h, and whenever it becomes conical or triangle things, you'll observe 1/3 of that. So that is how you can kind of remember volume. Normally it is sometimes given in the question also, but anyway, for a cone volume is 1 by 3 pi r square h. Now in this we have two variables, r and h. Fortunately we know the relation between r and h given to us, so we can substitute one for the other. Now we are interested in retaining h because we want to find dh of dt, right? So we'll write r in terms of h. So r is equals to h over 3. So that is what we will start with. So say, well, volume is equals to 1 over 3 pi, and instead of r we'll write h over 3 whole square times h, and that gives us, now we'll just open this up. So we have 1 over 3 pi h square over 9 h, and that can be written as 1 over 27 pi h cube. So that is our expression for volume in this particular case, correct? Now we can differentiate both sides with respect to time and find dH dt. So we have volume equals to pi over 27 h cube. Is that okay? So that is how we've written this equation. Now what is dV dt? Since with time both the things are changing. With time this cone is increasing in size, therefore the volume is changing, and height is related with volume. Both are related, so both change. So it's a case of related rates. So we can differentiate both with respect to time. So we get dV dt equals to pi over 27 3 h square dH dt. Now from here we can find dH dt, right? The expression for dH dt will be dH dt equals to dV dt times, so we can simplify this, right? So 3 will simplify into 27 as 9, and we'll cross multiply. So we get 9 over pi h square, correct? So that is dH dt expression. So we just multiplied this by 27. Before that we kind of simplified. Let me simplify it here itself. 3 goes 9 times, right? So it is pi over 9. So we got this 9 on that side. H in the denominator along with pi. Correct? So that is our expression for dH dt. And now we are close to the answer. So what is dH dt when r is 10 meters? When r is 10 meters, then what is the height? Let's write down. So when r equals to 10 meters, we say, well, when r equals to 10 meters, then h equals to 3 times r. That means 30 meters, correct? So we can say that, let's do it on this side. So we can say dH dt when r equals to 10 meters is same as when h equals to 30 meters, right? So we'll substitute h as 30 meters. We know dv dt as 225, correct? So that is what we'll do now. So we know dv dt is 225, so write 225 for dv dt, and then we have 9 over pi, and h is 30 for us, times 30 square, 30 square. So that is our answer. So what we can do, we can just calculate this out. So dH dt is equals to 225 times 9 divided by pi equals to, and we'll divide that by 900. And we get 0.71619, something like that, okay? So we can write this as 0. So let me write down here now. So dH dt equals to 0.716, right? So that is the rate of change of height, and the units will be meters per minute, right? So that is the rate of change of height when the radius is 10 meters, right? Sometimes you may be asked to give exact answer. In that case, you may simplify, write in terms of pi, correct? Now, so we can actually write that also. So it is like 9 over 900. You see, 225 times 9 over 900 pi, right? So 9 and 9 will cancel out. So we get 2.25 over whatever, right? So like that you can simplify and write down. But in any case, you get this answer as dH dt equals to 0.716 meters per minute as your answer. Okay? Thank you.